welcome back. Today is day 2 of the logs. And remember yesterday we talked about logs and that they are just an exponent. That's simple definition of a logarithm is an exponent. And yesterday we spent some time going back and forth between exponential and logarithmic forms. And today we're going to work with the properties of logarithms, and notice I've titled the properties of logarithms to know and love, and you need to know these properties and be able to use them, and you actually do know them, but you don't realize you know them. Since logarithms are just exponents, when you have the same base and you multiply, just like in the last unit, you simply will be adding your logs. Instead of adding exponents, you add your logs. So here I have a product, and here I have the sum. So I'm taking two logs and adding them together. So when you divide, here's my quotient, my division. I'm going to subtract my exponents, just like I do when I divide. I'm going to subtract my log. When I have a log of a power, that's like having a power to a power. We bring the power out in front and we multiply by it. So the a comes out in front of the log. If you have a log with a root, remember a root is simply 1 over the power. So the rule is still the same. It's going to come out in front. The logarithm of 1, the log base b of 1 is equal to 0. This is something you should know. And the log base b of b is 1. I can show you why here. If I turn this into Venn form or exponential form, my base is b, my exponent is what the log is equal to is 0, and anything to the 0 power is 1. Okay, and the log of a base, so if my base and my number are the same, my answer should be 1. And again, turning this into a Venn form or an exponential form, my base is b, my exponent is what the log is equal to is 1, and anything that is raised to the first power is itself. So that's why those properties stay as they are. So using these properties, we can solve some problems. If we have the log base 5 of 125 equals 3, and the log base 5 of 25 is equal to 2, find the log of base 5 of 125 times 25. So here is my multiplication or my product, and since I have a product, I'm going to add my two logs. So this is equal to log base 5 of 125 plus the log base 5 of 25. All I did is 125 is C and the 25 is D. So the log base D, which in this case is 5, of C plus the log base B of D. Now we're told in the problem that 125 is equal to the log base 5 of 125 is equal to 3. And the log base 5 of 25 is equal to 2. So we just substitute those both in. So my answer is simply 5. And if my bases are the same, and I'm multiplying, then I just add the exponent. If I were to turn this into a Venn form, 5 to the third is equal to 125, and 5 to the second is equal to 25. My 3 and my 2 are my exponents, so when I multiply, add them together, I get the 5. Find log base 2 of a. 1 using the product rule, or a using the product rule, and b using the power rule. So I can do this two different ways. first is a by using the product rule. So what that means is I have to take the log base 2 of 8 and turn it into the product rule. Well, what can I do with 2 to a power to make it equal to 8? Or the product rule. You want to do power, you want to do product, so I need to. What can I multiply by itself? How many times to get to 8? So it would be 2 times 2 times 2. Since I have the product, I'm just going to add my logs. Log base 2 of 2 plus log base 2 of 2 plus log base 2 of 2. And when we were talking about our properties up on top, when our base and our number match, our answer is just 1. So this is 1 plus 1 plus 1, which is 3. For B, using the power rule, I'm going to rewrite 8 to the power of 2. So log base 2 of 2 to the third. When you have a power rule, you take the exponent and pull it out in front. So this is 3 times log base 2 of 2. And our properties up on the top, and our base and our number are the same, our answer is 1. So 3 times 1 is 3. So basically what I'm showing here is it doesn't matter which rule you use, you still end up with the same answer. Find the value of log base 12 of 9 plus the log base 12 of 16. Well, okay, so if I am adding logs, that means I must be multiplying my bases. So I have the log base 12 of 9 times 16. I'm actually going to multiply 9 times 16, which will give me the log base 12 of 144. Now, what I need to do is turn this into a benefit. What's my base? What's my exponent? What's my number? Well, the base is 12. Exponent is what the log is equal to, so we don't know what that is. And my number is 144. So when I write that into exponential form on my den form, I'm going to say 12 to the what is equal to 144. Well, we know that that answer would just be 2. 12 squared is 144. If the log base 10 of 3 is equal to x and the log base 10 of 5 is equal to y, express the log base 10 of the square root of 3 divided by 5 squared in terms of x and y. So basically what I need to do here is use my properties and expand. This is the type of question where I need to expand. So we have log base 10 of 3, and I'm going to rewrite my square root as a 1/2 power over 5 squared. That way I'm using exponents instead of radicals. That's easy. Now, because I have a division, that means I'm going to subtract my log. So I have log base 10 of 3 to the 1/2 minus log base 10 of 5 squared. When they have exponents, I need to bring my exponents out in front. I will have 1/2 log base 10 of 3 minus 2 times log base 10 of 5. And if I go back to the original problem, log base 10 of 3 is equal to x. So in place of log base 10 of 3, I put x. So I have 1/2 x minus log base 10 of 5. We go back to the original problem. Is y. So minus 2y. So all I did was substitute an x and y for log base 10 of 3 and log base 10 of 5 after I've expanded that problem. Alright, I'm going to add another example to this. This is the other type of question you would likely see. Right? And a single logarithm. This would be what I call condensed. Alright, our problem is 1/2 log base 3 of x minus 5 log base 3 of y plus 4 log base 3 of z. In this case, we're going to take our properties and work them backwards. So before, when we had an exponent, we brought it out in front. Now, if we have a number out in front of our log, we're going to take it and put it in the exponent. There are 3 coefficients here, and I'm going to take all of my coefficients and turn them into exponents. So I have log base 3 of x to the 1/2 minus log base 3 of y to the 5th plus log base 3 of z to the 4th. Here I have a minus sign. Here I have a plus sign. That means I'm going to have a division and I'm going to have a multiplication. And I need to condense this into one single log. So I do have the log base 3, and I have x to the 1/2 divided by, because that's a minus sign, y to the 5th, and then plus log base 3 of z to the 4th. Because it's positive, the z to the 4th goes in the numerator. Okay, all negatives go in the denominator. And all positives go in the numerator. Okay? So when it says to write it as a single logarithm, we're going to condense it. We're going to take all 3 of these terms and turn them into one log. And we're only going to use the log with its base once in the final problem. If you go back up to example number 4, you see that they gave you the problem as a single logarithm. Okay? And then what we did is we took it and we expanded it. We took our exponents and put them out in front, and then we subtracted first because it was division, and we took our exponents and put it out in front, and then we made a substitution for x and y. here, it was already expanded and we needed to condense it. So we take the coefficients and put them into the exponents, and then we have a subtraction and an addition, and the subtractions go in the denominator and the additions go in the numerator. Okay, and this wasn't too confusing for you, but know that we do work on this in class, and we will do a lot of practice with it. These two questions here, examples 4 and 5, are the types of questions you see a lot on the entrance exams, whether it be in a part 1 or maybe even in a part 2 for 2 points. Alright, good luck, and we will see you tomorrow.